Okay, so we have three problems with proportionality. First one, y is directly proportional to x, and y is your g number when x is your a number. What's the value of y when x equals d? So let's just number these. 1, 2, 3. So we keep track of which one is which. Okay, directly proportional. This is 1. Okay. Let's specify very clearly what G, A, and D are. So let's see, it's 22, 7, and 12. Then we get y is g, so that's 22, equals k times x, when y is 22, when x equals 7. So k equals 22 sevenths. Now, so let me skip this step where you wrote out what the proportionality is. You want to be able to interpret the statement directly into an equation rather than skipping to the idea that k is going to be y divided by x. That's not as intuitive as k, y is directly proportional to x, okay? So, when you do the homework, maybe you get in the habit of doing that. You really don't want to skip that step. Okay? You don't want to skip steps in this course, and really any course, unless you are really, really familiar with it. You've done it hundreds of times, and are absolutely sure to skip your stepping is okay. Okay, well, so make sure this is real important. This up here. Okay, now. Y is 22 sevenths of x. If somebody went change that to a decimal, you're going to have to round that decimal off. So you're going to lose your accuracy. Now, in most cases, if you use enough significant figures for practical purposes, that wouldn't be a problem. But you want to get used to being able to express exact results. If these were symbols rather than numbers, you'd have to use a fraction. And you have to be able to manipulate the symbols in the same way you manipulate numerators and denominators and fractions. Okay, so you kind of want to keep things there, and you can eventually do an approximation, but I don't recommend it when you're first doing problems. Okay, so y equals 22 sevenths x, and I don't, it doesn't matter that maybe open math wanted decimal results. Okay, that's fine. That's what you're going to have to do. But work it out with fractions until in the last step you get a fraction, and then you can round that off. You can calculate that as a decimal rather than carry the decimal through every step. Okay, well, y equals 22 sevenths x. So x equals 12. Then y equals 22 sevenths of 12. So you write this up because people need to understand 22 sevenths. People need to understand how fractions work. soon enough, sooner than you really want. You're gonna have to be doing fractions with polynomials. Okay, and you see what that means when you get to it. You want to be sure you understand it at this point. So that ends up, let's see, 220 and 44 is 264. 264 over 7. That's 7 early there, and then we're going to know. Okay. Now I calculate that. 7 goes into 280 40 times. Okay. So it goes into 266 38 times, 265, 256. I'm losing my arithmetic. 259 times. Okay. So that's 37 and 5 seconds. It's about 37.71. Now you're going to use a calculator for that, and you just maybe calculate it at this step. If the numbers are simpler, you do some division stuff and then check it with your calculator, because it's always good to exercise your ability to do arithmetic. And I can't guarantee I did that right. I'd check it if I really needed it. Okay. So number 2. Y is inversely proportional to X. That means Y equals K over X. And let's say Y equals, I use 7 for A, so I'll use it again. X equals 18. So 7 equals K divided by 18. Thus, K equals 7 times 18, leaves 126. And I do that twice in my head. You know, 7 times 10 is 70, 7 times 8 is 56, 70 and 56 is 126. Or 7 times 20 is 140. Subtract 7 times 2 to get 7 times 18. And I subtract 14, I get 126. I'm just saying that because I check it twice when I can. I kind of double check myself down there, but I'm still not sure everything's right. Working memory is not what it used to be. Okay, so anyhow, so we get this. Thus, Y equals 126 over X. Now, if X equals, well, let's go back to my G number, which I used 422. And that's 5 and 16 over 22, which would be 8 over 11. 8 11ths is about 0.7. About 5.7. Again, I want to go check that. Now, 2 things. Okay. Y is getting bigger, right? I'm sorry, X is getting a little bigger. X goes from 18 to 27, right? Is that a big jump? Is 27 a whole, or 22? Is 22 a whole lot bigger than 18? Well, no, it's not even 1.5 times 18, right? So it's a little bit bigger than 18 proportional. Okay, which means that when X changes from 18 to 22, the inverse proportion will cause Y to decrease by that much. So is 22 bigger than 18 by about the same amount? 5.7 is less than 7? Well, 22 is a little bigger than 18. 5.7 is a little bigger, little less than 7, right? Okay. You can say X is quite a bit less than double. 22 is quite a bit less than double 18, right? Which means if X was double 18, the inverse proportion would make Y half as big as 18, which would be 3.5, because Y is 7, is half as big, it'd be 3.5. Well, X isn't nearly twice as big, and Y doesn't go down from 7 nearly to 3.5, does it? That makes sense? Okay, well, all we're saying is X gets a little bit bigger, so Y gets a little smaller. That's how inverse proportions work. Over here, what happened? What happened to X? X went from 7, I probably should have written this out. It went from 7 up to 12, right? So X almost doubled. What happened to Y? Well, Y should almost double. So just checking this for plausibility, Y starts at 22 and goes up to about 37. Well, if Y went up to 44, it would double, right? So X almost doubles and Y almost doubles. So I can say here, X nearly doubles, so Y nearly doubles. That's how direct proportion works. X get 10 times as big, Y is going to get 10 times as big. Over here, X increases a little, so Y decreases a little. That's how inverse proportionality. Now let's look at the third problem. Probably don't have room to put this standard here. Okay, so what we have is Y is proportional to the square of X. So Y equals KX squared, not square root, right? Remember, we have the squaring function, and you saw in the open math assignment a square root function, right? It doesn't have the word root on it. It's not a square root, okay? So I'm sure you understand that, because a huge difference between squares and square roots is in proportionality. Okay, so Y equals KX squared. Now, let's say Y equals 22. When X equals 7. So right there we can stop. We can write out what, find Y when X equals 6. We'll write that out when it comes time to do it. Okay, so Y equals 27 when X equals 7. So 22 equals A over 7 squared. Okay, equals 22 times 7 squared. Well, 7 squared is 49, which is almost 50. 22 times 50 is 1100. So all I've got to do is subtract 22 from 1100. I get 1078. Okay. Now you check my arithmetic, it's not always right, but now. Y equals 1078 over x squared. You can check whether that's really true by plugging in x equals 7. You divide 1078 by 7 squared, which is of course 49. And if I did my arithmetic right here, it has to give you 22. So if I made an arithmetic mistake, I can divide 1078 by 7 squared. And if you're trying to be right and want to be sure you're right, like on a test, when you have enough time to do it, check everything. Okay, so y equals 1078 over x squared. Now, if x equals c, which we'll say is, let's say 11. Okay, now let's think about it. 7 squared is 49. 11 squared is 121. Okay, so if x is 11, its square is between 2 and 3 times, because 49 is about 50, right? 121, just say 120. Well, if you double 50, you get 100. And then triple 50, you get 150. So it's kind of almost halfway between 2 and 3 times as big. So y ought to be between 2 and 3 times as big. So you can anticipate. And you can kind of do this in your head. I mean, if you 2 times as big as 22, that's easy, that's 44. 3 times as big as 66. So you figure it's going to be somewhere in the low 50s. If you get something that isn't in the low 50s, then you go back and figure, did I think that through right? Or did I mess up my algebra or my arithmetic? Okay. So anyhow, if x equals 11, okay, well, 120 goes into 98 times. So something's wrong. My thinking. I did something really boneheaded. Y is proportional to the square of x. Y equals kx squared. So 22 should be k times 7 squared, shouldn't it? See why I told you not to write things like this until you write this? And then be careful, like I'm not. Okay, so I pretended to make that mistake so I could illustrate that point. No, I don't know why I wrote it that way. I wasn't thinking, obviously. So I got to erase all this effort here. On a test, you don't have to erase, so you just cross it all out. You can't bring yourself not to be needful and erase it. But, okay. What I should have written here is y equals k times 7 squared. If it had been an inverse proportionality, k over x squared, it would have worked. So you see, and playing around with the numbers, just looking at what I was going to expect. I expected y to somewhere between double and triple, didn't I? Okay, and I found that y actually decreased from 22 down to 6 point something. Actually 7 point something. Okay. And at that point, I got confused just for an instant, but pretty quickly saw what I'd done. Okay, and you're going to do things like that too when you're working on stuff. Okay, I can do it. You have permission to do it. If I'm checking, you don't have permission to do it and not check. Okay. Okay, so y equals K times 7 squared. I was actually thinking ahead to this step when I wrote that down. Not a good idea. So K is 22 over 49. So y equals 22/49 of x squared. Now, if x equals, what did I say? I didn't. But I was going to say, let's see, what did I do before? Square root of 11. So if x equals 11, you get 22 over 49 times 11 squared. And I'm going to write that now, 121. What I'll write is 121 over 1. Remind us to multiply numerators and multiply denominators. Okay. And I really don't want to try to figure out accurately what 22 times 100. Well, it'll be, I don't want to fix that part. Okay. So I'm just going to say, well, 22 over 49. 49 into 121 is about 2.4, a little more than 2.4. 2.4 times 22, 22, 4,800, 48. Yeah, I'm losing track of my numbers. So somewhere around 32. Okay. Get the numbers. Forget. Let's step to the number. Okay, so is that right now? We expect x to more than double, but less than triple. Okay. Well, if you double x, which was 11, you get 22. If you tripled it, you get 36. Sorry, if you that's 2.4. Okay, 44 and about 54. Probably closer to 53. Did my arithmetic wrong. And again, I checked it by thinking. You understand what I'm thinking? I'm thinking that x squared is going to between double and triple, because x squared goes from 49 up to 121, right? If the x squared goes from 49 to 121, that's a little more than, that's between doubling and tripling, a little closer to doubling. So that directly proportional to the square, y should a little more than double, between double and triple. If it doubled, you'd have 44. If it tripled, you'd get 66. 54 is between 44 and 66 and a little closer to 54. Now, if you can think those numbers or write them down or whatever, and think in terms of what the proportionality is telling you, you'll have a deeper understanding and you'll be able to better apply it. Okay. I want to do one more because every night I walk the dog. And it's a little bit after dark. Not when I do that, after supper. After I feed myself, feed my wife. then I walk the dog, then I walk my wife. Okay. I walk the dog, my wife. And I take the dog. And it's usually a little delay between supper and the time I do that, because my wife takes longer to eat, and then the dog has to lick the plate. And the dog ain't going for a walk if there's food to lick off the plate. Okay, well, we've been noticing the strange light in the eastern sky after sunset. Anybody else notice that? Really bright. Okay. And I'm thinking, man, that thing is really bright. That looks brighter than Venus. But Venus is near the sun, which is over there in the west. And this is over in the east, so it ain't Venus. Okay. Way brighter than any star, Sirius, the dog star, will be rising soon. It's probably already rising, but maybe a little hard to see on the horizon. Okay, but within a month, you'll be able to see Orion and Sirius and all that stuff. So it's in the ecliptic. It's obviously a planet. It's really bright. It's not twinkling. Either that or it's a death asteroid coming at us, and we don't hear any reports about that. Okay. So, and if it's that bright, it would have killed us already. Okay. Because if it's that bright, it's pretty close, and it's moving at like 30,000 miles an hour relative to us. It doesn't take long to get to that point. So keep getting bigger and bigger. Okay. Don't worry about it. That's, there's plenty of things to worry about getting you. It's a long-term issue for humanity, because it did it to the dinosaurs. It could do it to us too. COVID causes all the problems it is. COVID is a little minor thing compared to, 10 years of nuclear winter or asteroid winter. Well, I'm digressing. Okay, so it's not an asteroid. So, at first we lived in fear. We sacrificed chickens and stuff like that to keep it away. Okay. But then we came to our senses. We used a little bit of science, a little bit of rationality. It's got to be a planet. And it's got to be Jupiter, because I knew Jupiter was our opposition. We go around the sun, and Jupiter goes around the sun much further out and much slower. So we keep passing Jupiter. Every year we pass Jupiter. Now, sometimes Jupiter's closer to the sun, and sometimes we're a little further from the sun. And if we get really far, get at our furthest from the sun, which isn't all that far, much further, because our orbit's nearly circular, but it's a little bit elliptical. And Jupiter, which has a little bit more ellipse, happens to be in the close part of its ellipse, then it's much brighter than usual. Same thing kind of happens with the moon. Sometimes full moon occurs when the moon's a little closer to the Earth than the moon is there. So Jupiter's probably, pretty close to as bright as it's going to be in the next 1,000 years. Or at least it was a few days ago. I won't get into that. Okay. So I did some calculations. They're all proportionality calculations. Okay. How close can we get to Venus? Okay, well, it's a little complicated. Because when we're closest to Venus, that means it's between us and the sun. And we can't see it. It's got to be kind of over here, and the sun's over here. And then we're only seeing a crescent. I don't know if you've ever seen the disk of Venus, but you can't see a round disk of Venus. It's closer to the sun than we are, so we're always seeing it most like a half moon. So when is Venus brightest? Well, it's a little complicated. I didn't work that out in my head, but I got a kind of an intuition. I figured, okay, yeah, it's probably about half as far from the sun as the Earth is. Half as far from the Earth as the sun is. Call that half an astronomical unit. I know that Jupiter is out there at about, I think, 7 astronomical units. Okay, now you're not going to understand all this detail. So we have one proportionality. Okay. Jupiter is maybe 7 times as far from the Earth as the sun, which means it's 14 times as far from the Earth as Venus would be when Venus is its brightest. Okay. Well, there's a bunch of other stuff, and I forgot one. I came up with a conclusion. Yeah, Jupiter could be brighter than Venus. It looked like the right thing out there. Okay. Then I looked it up to see, and Jupiter never gets as bright as Venus is, and Venus is visible. So, working it out, we have these proportionalities now. Okay. And why is brightness? X is distant from the sun. Z is the diameter of the planet. Just with this much, I'm going to call this absolute brightness. And that's how much light is reflecting off of the planet. Now, there are other factors. Venus is highly reflective. Jupiter is very reflective too, but not as reflective as Venus. I'm going to ignore that. That's too much. Okay, we'll just deal with these three things. Okay, so and let's start with absolute brightness. We've got the proportionalities here. Well, yeah, no. Absolute brightness is proportional to the area of the planet. Which is proportional to the square diameter portion. Okay. That's just because, well, it is a geometric proportionality. I don't want to go into all that. I would like to because it's important. Absolute brightness is proportional to the area of the planet, which of course is square root diameter. Okay. Absolute brightness is inversely proportional to distance from the sun. So y equals what? Can you write out the proportionality equation for this much of the analysis? There's more to it to get the final answer, but this is enough to illustrate a couple of important things. Okay, well, you start with y equals k, then you got to do something with x and y, and you got to do something with both of them. You can't write out two separate equations. I guess you could, but then you'd have to feed results from one equation into the other, and it would be a little more complicated what you do, because what you do is actually pretty straightforward. Okay, so absolute brightness is proportional to the area of the planet, which is proportional to the square of the diameter. So Z is the diameter. And what this comes down to then is the area is proportional to the square of the diameter. Brightness is proportional area, so brightness is proportional to the square of the diameter. Let's read that carefully. You're going to see that. So you're going to have a Z squared. You also have an inverse proportion. So we're going to need to do a fraction. And the fraction is going to be Z squared because brightness is proportional to the square of the diameter. And then you have an inverse proportion. Okay, to the, I said to the distance from the sun. No, it's the square of the distance from the sun. So when you were putting an X in the denominator, a lot of you did, say, oh, you missed the square. Well, no, you didn't miss it, I did. Okay. I'll just say the square distance from the sun. So it comes out Z squared over X squared. If it was inversely proportional to the distance, you'd write Z squared over X. Okay. So there's our proportionality equation. Now I'm not going to finish this. I could give you the two distances. Well, the distances are, let's say half. Well, actually, we're talking about brightness. Okay. Distance is about Venus about 0.7 astronomical units. Okay, and distance from of Jupiter is about 7 astronomical units. So Venus is about 10 times closer to the sun than Jupiter is. It would go from there. Okay, so I'm not going to torture this into a complete model. I might well do that in recalculus when we do proportionality, which we're going to do in a week or two. I'm going to use this as an example. And what you end up with here is if Z is 10 times as big, then Z squared is 100 times as big, right? Okay. If X is 10 times as big, and X squared is 100 times as big, okay? Which means if Jupiter has 10 times the diameter, but it's 10 times as far from the sun, which means it has about the same absolute brightness. Now, I don't think it's right, but that's what my conclusion is. But we're only seeing about half of Venus, and we're not getting a direct reflection, so all kinds of stuff comes into it. But then the other kicker is we're 10 times as farther from Venus as we are from Jupiter. And that all comes together. You know, we can easily write that out, but I don't want to lose you, and we got to go on to another topic, okay? Okay, got 2 points, 2, 4, 7, 9. I want to find the slope of that line segment. So I'm just going to ask, we're going to pause for a second, but I'm going to ask, what are the 2 words that come to mind when you think of the word slope? Okay, well, the 4 I had written here was kind of smushed into the parenthesis. Now it's going to give us an inconvenient slope. Too simple. It's going to be 1. Okay. So we asked, what's the rise? Okay, well, first I asked, what do you think of when you think of slope? Well, slope is rise over run. If the rise is from 5 to 9, so the rise is 9 minus 5, which is 4. You can cut that in your fingers, but everybody knows. Okay. The run. Is from x equals 2 to x equals 7. Okay, so the rise over run is 4 over 5, which is 0.8. Now, a lot of times the slope, you do want to write a decimal equivalent so you can really understand how big the number is, so you can relate it to a picture. But you first want to write the fraction. You don't want to just slot down the decimal equivalent. Okay, now. To illustrate that and give you a picture on the graph. I'm going to write rise, and I'm going to use delta y. The delta stands for change in. That's something I'm pretty sure you've seen, but if not, just a triangle, Greek letter, capital delta. That's equal to delta y, the change in y. Y changes from 5 at this point to 9 at this point, so the change is 9 minus 5, which is 4. Now, open math is going to give you a formula for this. It's going to be y1 or y2 minus y1 divided by x2 minus x1. Okay, formula is a good way to get the answer without understanding what you did. Okay, but the formula also keeps you straight and makes sure you do things in the right order. So the formula has a point, but the formula means what we're doing here. And I'm not even going to talk about the formula. Everyone's going to be able to use this formula. Don't confine yourself to the formula. Think in terms of pictures, because then you'll have something worth knowing. Formula is not worth knowing if you don't understand the picture. And the run is change in x, which equals 7 minus 2, which is 5. Slope is rise over run, which is change in y divided by change in x. And that's equal to 4/5. Or 0.8. I like to depict the slope. I write the result 0.8 here, and I put a box around it right over the slope, right over the hypotenuse of this triangle. So now I can read rise, run, slope at a glance without having to look at a bunch of words. But of course, I put the words around it, so if I don't remember how that 0.8 came about, I can see. Okay, so I can write it out here, then I can put that in a more concise picture that shows you what the slope is. So I recommend you do that. Okay, now. We have a straight line through these points. A straight line goes forever. Okay, so the straight line has the equation y equals mx plus b. Almost everybody uses these letters, although sometimes it's ax plus b. It's, you know, if I use mx plus b, that's what open math is going to do, at least most of the problems. So y equals mx plus b. Where m is the slope. Well, just like with proportionality, we have a pair of numbers here that we could substitute for x and y. We could use this pair of numbers, or we could use this pair of numbers. All we need is 1 point, one pair of numbers. And we can substitute here if we know the slope. So if we know the slope, which we do, we can figure out what b is. So we're going to substitute x, y equals 2, 5, with m equals 8, substitute into this equation. What do we get? Write out the equation we get. Using the x and y we get from the point 2, 5 and the slope 0.8, what's the equation? And then solve that equation for b. Okay. People got this very quickly. Y is 5, so you got 5 equals slope, which is 0.8, times x, which is 2, plus b. So 5 minus 0.8 times 2 equals b. Now, I haven't written out the intermediate step. Subtract the 0.8 times 2 from both sides, because that's obviously what we're going to do. If 0.8 times 2 is added to b, then to change this to just b, we've got to subtract the 0.8 times 2. And then we can do the calculation. So b is 3.4. So now we can say so having solved for m and b, we plug them in, we get y equals 0.8x plus 3.4. Now, if y equals 0, what's x? I don't bother writing that out. We're in a short time, and you can kind of do that pretty easily. So we're going to stop and see if we can, if somebody will tell me what it is. Oh, phooey, I don't think I recorded any of that. Well, I'll get it in a minute. Okay, so we've taken this information, calculated the rise and run, and put it all here of this line, and then we take the form of the straight line, and we put the information we have, which is now we know the slope, we know the x and y coordinates of one of the points, and we could have used 7, 9 as well as 2, 5. We would have gotten the same result for the value of b. Okay, but anyhow, we put that in, we solve for b, we get the equation of the line. It's quite straightforward. Plug the 2 in for y. Sorry, plug the 5 in for y. We have it here at this point. Plug it in for this y, we get a 5 here. Plug the 2 in for x, we get a 2 here. Plug the 0.8 in for m, we get this. And now we have simple arithmetic to solve for b. Now the equation of the line is then this. Okay. So if we have that equation, y equals 0.8x plus 3.4, an important question is, what's the value of y when x equals 0? That's easy to find. You plug 0 in for x, and the 0.8x just becomes 0.8 times 0, which is 0. So you get y equals 3.4. Now, so when x equals 0, y equals 3.4. That gives us a point on the graph, 0, 3.4. We call that point the y-intercept. If y equals 0, what's the value of x? Okay, well, how do we find that? You have the equation. If I give you a value of y or a value of x, you can find the value of the other one. We give y, you can find x. I give you x, you can find y. It's very simple. And that always gives you a point on the graph. Now, what we're looking for here is the point where y equals 0. And notice that y equals 0 where? Y equals 0 here and everywhere on the x-axis. The y coordinate of any point on the x-axis is 0. So what we're trying to find is the point where the line intersects the x-axis. I've already got that down here. But what we do is we plug y equals 0 into the formula. So if we place y by 0, we get 0 equals 0.8x plus 3.4. Then we solve for x, and that's very easy. Subtract 3.4 from both sides. You get 0.8x equals negative 3.4. Divide both sides by 0.8, you're going to get x equals 3.4 over 0.8, which is negative 4 and 4. We'll use decimals because we're putting these points of graphs. And it's negative 4.25. And all that makes pretty good sense in terms of the scale of the graph. Pretty good. The scale isn't quite right. The points don't really match those coordinates perfectly. But there it is. We call this the x-intercept. And the y-intercept and x-intercept are really important points on the graph of straight line. So I want to be sure we understand that much.